question 3.1. In question 3, we were told to consider the quadratic number pattern 3, 7, 12. The first question here is, show that the general term of this pattern is given by Tn equals half n squared plus 5 over 2n. To solve this question, we have to find the first difference, yeah? And we have to look for the second difference, right? The second difference is usually set to 2a. The first difference, the first term of the first difference is set to 3a plus b. And the first term of the series is always set to a plus b plus c. Now, how do we get this first difference? This first difference is gotten by subtracting the first term from the second term. So that will be 7 minus 3, that is 4. And this value is obtained by subtracting 7 from 12. 12 minus 7 is 5. Yeah. Now, for the second difference, all you need to do is to subtract 4 from 5. So 5 minus 4 equals 1. So once you have this, then you can begin to calculate each of these variables. So we will calculate variable A by setting 2a to the second difference. So that means we have 2a equals 1. And easily we can solve for a from here. So a will be equal to half. To solve for b, let's solve for b next. So to solve for b, we just have to use this first difference. And remember, the first difference is set to 3a plus b, and that will be equal to 4, the first term of the first difference. We have the value of a here, which is half. So we just make appropriate substitution. So it means that 3 multiplied by half plus b equals 4. So here, 3 multiplied by half is 3 over 2. So we move that 3 over 2 to the other side. So we have 4 minus 3 over 2. So 4 minus 3 over 2 is 5 over 2, right? So yeah. So 3 over 2 is the same as 1.5. So 4 minus 1.5 is 2.5, which is 5 over 2. Next, we have to calculate the value of C. So remember, the first term of the sequence is equated to a plus b plus c. Now we have the value of a, we have the value of b, so we can make appropriate substitution. So that will be it. I like working with decimal. So I will convert all we have here to decimal. 0.5 plus 5.2, then plus c equals 3. 0.5 plus 2.5 is 3. If you take that 3 to the other side, so that is what we see in the next step. I'm just breaking it down so it's simplest form for you guys. So we have 3 plus c equals 3. So that means that c will be equal to 0. C equals 0. So you can then substitute the value of a, b, and c into the Tn expression. Remember, the equation for the Tn for a quadratic sequence is Tn equals an squared plus bn equals c. So if we substitute the value of a and b and c into that Tn expression, we have a Tn equal to half n squared plus 5 over 2n, which is what we were told to prove in this question 3.1.1. Okay, question 3.1.2. It said, what number must be added to Tn minus 1, that is the second to the last term, so that the last term, so that the Tn would be equal to, so that the value of Tn will be equal to 13,527. So what we can do here is to look at the Tn expression by itself. So we look at the Tn expression itself, and since they said Tn equals this, all we need to do is to substitute Tn equals 13,527 there. So we do that, and we can transfer this value to the right-hand side in order to have a quadratic equation. So we have this quadratic equation and we set everything to 0. So we can solve everything on the calculator to get the values of n. So n in this case will be equal to negative b. So that will be negative 2.5 plus the square root, the square root of 2.5 squared minus 4 bracket a, our a there is 0.5, multiplied by c. Our c is negative 13,527. Then we close the bracket. We use the down arrow. And here you have 2 times 0.5, and that gives us a value of 1. And the value there will be 162. Now let's look for the other value of n. Remember, the first value is 162. So the other value of n will be 167. So let's see, for those of you that like to calculate manually, but in your matric, you are not expected to calculate manually. Just punch everything into your calculator. But during your preparation, in order to improve your math skill, or if you are the type that like to do things manually, you can just experiment with this. You can drill down. So n equals 162, or n equals negative 166.5. Right? So, but n cannot be equal to a negative value. So we would go with n equals 162. So now, let's write an expression for Tn minus 1. To write an expression for Tn minus 1, all we have to do is to substitute n minus 1 anywhere you find n in the Tn expression. And that is exactly what we did here. So instead of writing n here, we wrote n minus 1. And instead of writing n here, we wrote n minus 1. Next, we can expand this. So when we expand this, we can substitute n equals 162. This one can still be expanded further and simplified. We can expand this further and simplify it. And I'm doing that here. So we substitute n equals 162 there. So we substitute n equals 162. Then we have this 0.5 multiplied by 162 squared plus 1.5 into 162 minus 2. So that is what we have there, and we can simplify that further. So if we punch all this into our calculator, we have this. So eventually, we have Tn minus 1 equals 13.63. that is not the end of the question. Remember, the question is, what must we add to Tn minus 1 in order to have a Tn value of this? So we can write that word problem in this form. So we can say Tn minus 1 plus x equals Tn. And we make appropriate substitution. So we know that Tn minus 1 equals this, and Tn equals this value, 13,527. So we can make S the subject there. And doing that, we have a value of x equal to 164. So it means that you must add 164 to Tn minus 1 in order to arrive at a Tn value of 13,527. So the next question is question 3.2.1. Question 3.2.1. So we were given this arithmetic sequence with T1 equals 8 and T2 equals 11. Now they say we should calculate the value of n if Tn equals 41. Now to calculate the value of n when Tn equals 41, we would have to solve to get the common difference. Here, T1, which is equal to A, is equal to 8. And T2, which is equal to A plus D, equal to 11. So we can substitute A equals A so that we can get our common difference. So if you move that 8 to the other side, it becomes D equals 11 minus 8, which means that our D will be equal to 3. Now, to solve that question, we have to write an expression for Tn. Let's write an expression for Tn. So you know the formula for Tn is A plus n minus 1 into D. And we set that to 41 because that is the value that was given to us there. So here A is 8, then our common difference is 3. So if we solve that appropriately, we will come up with a Tn expression of 3n plus 5. Right, so that is what we have there. So if Tn equals 3n plus 5, it means if Tn is equal to 41, then it means that 5 plus 3n equals 41. If we transfer this 5 to the other side, we have 3n equals 41. So it will be 41 minus 5. All right, so that means 3n will be equal to 36. So 3n will be equal to 36. It means that n will be equal to 12. So it means that n will be equal to 12. So this means that the value of the term in position 12 of this sequence will be 41. The value of term 12 in this sequence would be 41. So that is very important, and we would use that when solving for question 3.2.2a. When we are solving this question, we have to use this. So let's look at that. So question 3.2.a. Now, let's look at that question 3.2.2. A new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. For the new sequence, P8 equals 1 and P11 equals 2 and so forth. Now, they want us to write down the value of P41, that is the value of the 41st term in the sequence Pn. So for sequence P, if you compare sequence P with this original sequence, you would see that the value in this sequence P is the position in sequence T, in the original sequence. If you compare sequence P with sequence T, you would see that the value in sequence P correspond to the position in the original sequence. If you look at this P8, it means that the value of the 8th term in this new sequence P is 1. So if you compare very well, you will see that the value in sequence P equals the position in the original sequence, and the position in sequence P is equal to the value in the original sequence. So it's just a kind of a switch, right? So if we look at this question 3.2.a, bearing in mind that the position in sequence P is the value in the original sequence, it means that the value of the 41st term in this new sequence P would be the position in the original sequence. So if you look at what we calculated in question 3. If you look at what we calculated in question 3.2.1, you will see that the position of 10 that will give you a value of 41 in the original sequence, the position of that term is term 12. So it means that the value that will occupy the 41st position in the new sequence P will be 12. It will be 12. So all you just need to do here is to substitute this 41, right, which is position 41. You substitute it into the Tn expression, right, into the Tn expression for the original sequence. So if you put 41 here and you solve for n, you will arrive at an n value of 12, which is what we have here. So this position in the original sequence would correspond to the value in the new sequence P. Therefore, the value of the 41st term in the new sequence P would be 12. That is why it's just a 1 mark question, right? It's just a 1 mark question. So that is that. So you can see here that this is P8, that is the 8th term, equals 1. So how you solve this is, if you substitute 8 into this place, you will get an n value of 1, right? If you substitute 11 into this place, in place of Tn, you will get an n value of 2. So like I said earlier, this for sequence P, the value in sequence P represents the position in the original sequence, which is T. Let's take that as T sequence. If you look at these two, you will see that the value of these two, this value 2, represents the position in this original sequence. If you substitute 1 into this n, for example, you get 8. If you substitute 2 into this n, you get 11. So it means that the value in this P sequence represents the position in the original sequence, right? So therefore, it means that the value of the values in the P sequence correspond to the position in T sequence, and the position in the P sequence will correspond to the value in the T sequence. So you just have to look at the question and know the trick they are trying to play there. So if we look at it, we see that the value of P41 would be the end position in Tn sequence that corresponds to a value of 41, which we have already calculated here to be 12. So that means n equals 12. B, 3.2.2b. And the question there is for us to calculate the first term of the new arithmetic sequence. So the first term of the new arithmetic sequence would be, the first term of the new arithmetic sequence will be the term that occupies position 1. So that means that n is equal to 1. And remember to calculate the value. Remember to calculate the value of the term in sequence P. You have to use the end position for sequence T. So what really happened is that we can come to the nth term in this sequence A, and we know that that is equal to 3n plus 5, right? So that is what I'll be doing here now. So we know that Tn equals 3n plus 5. So what will we do to calculate the value of the first term in the new arithmetic sequence P is to substitute n, which is equal to 1, in place of Tn. So we put 1 here and we solve for n. So that n that we get here will represent the value of the first term in sequence P. So let's see how that works out. So we substitute 1 here, since we are dealing with n, the first position, which is n equal to 1. We put that 1 here and we solve for n. So if you bring this positive 5 to this side, we have 1 minus 5, and that will be negative 4 equals 3n. And if we solve for n will be equal to negative 1.33. But n must be an integer, right? So we have to approximate that to the nearest whole number. So that means that n equals negative 1. We can try that for the second term in this Pn. So for the second term, we have to make Tn equal to 2 and solve for the value of n. So if we make Tn 2 for the second term, P2, if we solve for the value of n, if we take this plus 5 to the other side, it becomes 2 minus 5, which is negative 3. And if we make n the subject, n will be equal to negative 1. Now, let's try the third term, P3. So for P3, we make Tn equal to 3 and we solve for n. So n would be equal to negative 0.66. If we approximate that to the nearest integer, to the nearest whole number, we have n equals negative 1. So here we could see that this is a kind of a repeated block sequence with 3 identical numbers in the same block. So term 1 will be negative 1, term 2 will be negative 2, term 3 will be negative 1, and term 4 would increase by 1. Term 4 will increase by 1. And the reason I said that is that if you come back to this solution, you will see that we have P1 here and P2 here. So if we subtract this, right, 2 minus 1 is 1, right? And 11 minus 8 is 3. So it means that for every 3 consecutive term, the p-value would increase by 1. All right, so the first term here, which is p1, will be -1. The second term would also be -1. The third term will be -1. And the fourth term, the fifth term, and the sixth term will be 0. So the seventh term will be 1. The eighth term, as we saw here, the eighth term will be 1. The ninth term will be 1 as well. The 10th term will be 2. The 11th term will be 2. And the 12th term would be 2 as well. And if you drill down up to the 41st term, the 41st term will be equal to 12. That is the solution to question 3.